Good morning, everyone. I hope you are fine. Today, we will complete the second lesson in our quarter 4, the magnet and magnetism. In the previous recorded video, we explained what is the magnet, what is the magnetism, and classified the materials according to the ability to attract to the magnet into two types: magnetic material and non-magnetic material. Rapidly, let's remember what was explained in the previous session. Firstly, what is the magnet? Magnet is a piece of rock or metal that attracts or pull the certain or a certain kind of metal toward itself. Not all metals attract to the magnet, and the force of the magnet is called magnetism. The force of magnet is called magnetism, and material classified into magnetic material, which is the materials attracts to the magnet. Non-magnetic materials not attracts to the magnet. Today we'll know from where the magnet gets its force, or what is the source of the force of the magnet. Basically, every magnet consists of two poles. Let me show you the photo of magnet to understand this part. You can see that the power magnet, or the U-shaped magnet, this is called power magnet, like the chocolate bar, and U-shaped magnet or horseshoe magnet, both of them are correct, consists of two poles, south and north pole, and here north and south. Okay, so any magnet consists of two poles, north and south. Inside the magnet, we know that magnet is made of metal, and metal consists of atoms. Inside these atoms there is electrons. We can say it electric charges. These electric charges, when it spinning or pass through the magnet, it causes force. Simply to understand this point, we will explain this part on the electric wires. We know that electric wires are made up of copper. Copper is metal. The electric charges pass through the copper wires between its terminals from end to another to transfer the electricity. For example, when you switch on the electric key, for example for the electric lamp, the electric charges begins or start to move or pass through the electric wires from the switch till to reach the lamp, so the lamp will turn on or lightening. Without the spinning of this electric charge, the electricity will not reach to the electric lamp, so it will not lightning. It's similar in the magnet. The electric charges inside the magnet spinning, which means moves. This movement causes the force of the magnet. Again, this movement or the spinning of this electric charge causes the force of the magnet. And we know that the magnet have two poles, north and south. They are called magnetic poles. Magnetic poles means the two magnetic poles, south and north. Okay, if we do an experiment, you can do it in your house. If you have two magnets like this, if we have two power magnets and we approach the similar poles to each other, which means we approach south to south and north to north, what will happen? You will find that the similar poles, north and north, south and south, will repel. Between them will arise a force called the repulsion force. So they will repel, moves away from each other because they are similar. But when we approach the dislike or the different poles to each other, they will attract. Why? If you remember that we say that the magnet have electric charges inside north pole and inside south pole. Basically, the electric charges inside south pole is similar to south pole in another magnet, and the electric charges in north pole similar to the north pole in another magnet. So the electric charges in the same poles similar. They are similar. So they will want to make cooperation to each other or attracts to each other because they are similar. But different charges like to cooperate with each other, like to attract to each other. Okay, for example, if you examine your remote control of your TV, when you check the dry cell, you find that on both terminals you find positive charge and negative charge. Did you ask yourself if we replace, for example, negative charge by positive, so it will be positive and positive, what will happen? Or not negative and negative in the dry cell, what will happen? There is be electricity or not? Did you ask yourself before? So it is the same in the magnet. So basically the different charges or the different poles like each other, so it will attract, but different poles will repel each other. I hope you understand this part well. Okay. For example, if we have a magnet and we put around the magnet magnetic material like iron nails, and we draw two circles, small circle and big circle, around the magnet. In the small circle we will put iron nails, blue colors for example, and in the big circle we will put iron nails with red color. In the first circle, the iron nails with blue colors very near to the magnet, but in the big circle, the red iron nails very far from the magnet. Which one of these groups will attract strongly to the magnet? The first iron nails, blue colors in the small circle, or the red colors in the big circles? Exactly, the nearest one will attract very strong to the magnet because they are very near, very close to the magnet, while the far away or the big circle or the red iron nails, their attraction will be very weak. So you can say that around the magnet there is area, this area surrounding the magnet. In this area the force of the magnet appears, which means inside this area, very near to the magnet, the most powerful of attraction of the magnet arises. As you moves away from the magnet, or there is a big distance or large distance from the magnetic material and the magnet, the attraction force will decrease. The attraction force will decrease. And you must know that the attraction force, or the most powerful of attraction force of the magnet, in their poles, but in the middle of the magnet the attraction force will decrease. The magnetic attraction is weak in the middle of the magnet. Maybe you ask yourself, Mister, why the poles of the magnet north and south? Whether it, for example, east and west, why they are north and south? To answer this question, you can search on Google to see this experiment. There is some scientists hanged a magnet in a stand by thread and let it hang it free, moves free. He find that the magnet changes the direction of its terminals to become one of its end look up to the north and the other end looks down to the south. You can check this experiment on YouTube, or you can do it by yourself in your home. Okay guys, I hope you understand this part well, and see you soon in the next video. Thank you for your watching. Goodbye.